Hello there, video 5 on this series. My name is Dick van Oeveren, and in this video I'm going to show you how to provision and how to configure EVPN VXLAN on Aruba CX switches in the data center. So this video is part of a full video series. I believe it's like 11 or 12 videos. Maybe there's some bonus stuff coming as well. You never know. But in this video, it's going to be EVPN provisioning. And let me just show you the diagram. It's this. And so what you can see here is I have a couple of vSphere hosts sitting here coming off the 10K switches, and I'm going to create an EVPN overlay that allows you for these VMs that are sitting here. So the 10.6.201, 102, for example, 10.6.202, 110, all those VMs allow them to communicate with each other using a VXLAN tunnel and an EVPN VXLAN control plane. So that's what we're gonna configure. There's a whole bunch of things that we need to do there. And let me also show you that. Here you go. And so you can also see that we already did quite some stuff here in the previous videos. Again, we're on video 5, so what we're going to do is create some networks. We'll configure some access ports on the 10K so that they have access to the relevant VLANs. Then I will be creating the EVPN instance, also a layer 3 VNI for the VLANs so that we can do routing in the overlay, routing on VXLAN. And then obviously we want to see whether everything works by verifying the connectivity. Okay, so let's start by configuring the networks. We're on the dashboard here of AFC, and so what we're going to do is, so there's actually a couple of different ways to get these VLANs working. Now, so normally what you don't have to do is so if you go into the VRF, right? So let me just show you the first option here. I can go into that VRF and select networks, and I can create the networks here. I can create the VLANs here, but it's not necessary to create them here, because the only reason why you would create a network in this context is that if you want to use these networks later on to redirect traffic to the security chips on the 10K switches. So it's not necessary to configure those or to create those networks here. It does come in handy if you want to, like, use these networks later on to redirect traffic. So for now, I'm not going to configure the networks here. Instead of that, the only thing you need to do in order to get the VLANs configured on the switches is just to assign the VLANs to the interfaces. Now, let me just select the two 10K switches, because these are the switches that we will be using. You can see that the links, let me just also filter on the link state. So you can see that on the 10K1 interface 1 and 2 is up, and on the 10K2 interface 1 and 2 is also up. Now the hosts, I just showed you the diagram. So the hosts are connected to interface 111 of the 10K1, and they are connected to 112 of the 10K2. So I select those two interfaces, and then what I can do is go to Actions, VLANs, and then I'm going to add VLAN 1201 and 1202. These are the two VLANs that are configured on the port groups of the vSphere hosts, and those two VLANs, we're going to use those two VLANs to communicate between the workloads that are assigned to that port group. Okay, let's apply. You can see that the VLANs are applied to the interfaces. Now let's create the EVPN instance. So in configuration, to go to routing and select EVPN. And then what we do here is in the EVPN section, we just add a new EVPN fabric. And what we can do is we can either select the whole fabric, entire the EVPN instances across the entire fabric, or we can just select switches. But again, we'll just deploy the EVPN across the whole fabric. Just give it a name. I don't know, GPA EVPN. And then we can do the VNI mapping. Now remember that we are using VLAN 1201 and VLAN 1202. So we're going to map those VLANs to the VNI, and I don't know, the base VNI, let's say 1200. So what will happen is that once the configuration is provisioned, VNIs will be created, and then the VNI numbers will be 1200 1201 and 1200 1202. Okay, yeah, so we got the MAC address resource pool again, so assigning the MAC addresses. This is also, for example, if you want to use Active Gateway, those types of things, we're going to use MAC addresses from that pool. And then for the root target type, typically for IBGP, we select auto. Again, if you want to know more about, as I said that in the introduction, if you want to know more about protocols and how they work and why you would select root targets, auto or manual or whatever, my colleague Joe Neville has created a lot of great videos covering all that deep technical stuff, and they're very valuable and very good information source. Okay, so I highly recommend you to check those out if you want to know more about protocols. Okay, and then the summary, and then then I can click apply. Before I do that, let me just move into one of the 10K switches. And see what happens in terms of configuration. Show running. There should be no EVPN or anything in here, right? So if I do a Q show run begin EVPN, there is some EVPN in there, but this is the BGP configuration. So there are no SPIs or anything, and no VXLAN interface. Okay, I can show that as well. Let's see. Yeah, let me just do an include VXLAN. That might work better. Okay, so there's a VXLAN interface, but there's nothing configured in there. Okay, hit the apply button, and you can see that the EVPN is being provisioned. And then if we do, we can see now that there is an EVPN configuration in here. Right, so there you go, with the two VLANs in there. Okay, do a quit show run interface VXLAN. And you can see the VNIs here. It's actually 2401, 24. So it's adding, it's not appending, it's adding the value. So it's 1200 plus 1201 and 1200 plus 1202. Okay, and then so you also see this VNI 120,000, which is the layer 3 VNI that we've created earlier when we created the VRF. Okay, cool. Next is to create the layer 3 VNIs or the IP interfaces for VLAN 1201 and 1202. And so by creating those SPIs, that will allow you to route in the overlay between those VLANs. So let's do that. Let's go into that VRF, go to IP interfaces, And so you don't see the networks here, so I haven't created the networks, but the VLANs do exist. Go into IP interfaces and then create a new SVI for VLAN 1201. And so what I'm going to do is I'm only going to select the leaf switches. I don't need the spine switches because typically the spine switch do not participate in the in the VTAP. So typically a spine switch is not a VTAP. So I'm just gonna create the SVI on the leaf switches. So the IP address would be 10.6.201.0/24. And so the IPv4 addresses. So what I can do here now is I can enter a range of IP addresses, and these IP addresses can be assigned, they will be assigned to each switch individually. So 10.6.201. I don't know, 10, for example. Okay, my active gateway address. And now, so this is the active gateway address that will be used by each VTAP. What this means is that every switch, every leaf switch will use this IP address as the first hop default gateway for the VMs that are connected and going into that overlay. So what that means is that it doesn't matter where your workloads are, they will always use the same default gateway, in this case 10.6.201.1. Okay, virtual Mac. Okay, so that would be that. Just give it a description. IP interface VLAN 1201. And if you're happy with the settings, apply. Okay, and you can see that the SVI is being applied to all the leaf switches. Now we need to repeat the same step for VLAN 1202. Again, select all the switches and then remove the spine switches. 10.6.202.0/24. My active gateway will be 10.6.202.1. And then a active gateway MAC address. 1202. Let's use the proper naming here and apply. And these are the IP interfaces. So you can see 1200, 1201, and 1202 here being applied to the respective switches. And now that I've created 1201 and 1202, what I also need to do is remember that I have this, say, this link aggregation from the 8360.3 going to the 8320. And now I have configured VLAN 1201 or network 1201 and network 1202 on that 8360, but it's not configured on the link. It's not assigned to that link aggregation going out. And that's something that I also need to do. Really very easy. Go to port link aggregation groups, select the link aggregation group here, which is the GVA2 8320. You can see that I only have VLAN 1200 assigned. Go into the actions, go into VLANs, add, and then add VLAN 1201 and 1202. Apply. And now you can see that all three VLANs are applied to the link aggregation. Now, before I show you the connectivity, so verify the connectivity, there's one final action that needs to be performed, and that is to enable BGP in the on the VRF. That's because, so the reason why you need that is that for symmetric routing to take place, a specific route type is exchanged. Again, check out Joe Neville's videos on BGP and EVPN VXLAN, they're great. So we need to exchange this route type 5 information. And in order to be able to exchange that route type 5 so that the VTAPs know about the subnets, we need to enable MPBGP on the VRF. Okay, so let's do that. Let's go into the BGP configuration. You can see that the VRF is there. Just select that VRF, click on Edit, and enable BGP on there. And so we're redistributing connected routes. So yeah, so that's all fine. Click Apply, and then we should be good to go. So before we check out the connectivity, let's check out whether we can see some host information, right? Whether we get some type 2s in, basically. Let's check it out. From the configuration, let's go into routing VRF, select the GVA VRF and go to the routing table. You can already see some EVPN routes here. Let's scroll down and filter on EVPN. So these are the EVPN routes. And what you can see, for example, here is that in the next hop address field, you can see this VXLAN VNI 120,000 here. So this means that this entry is using the layer 3 VNI. It's going out, and also the VXLAN VNI. So here's where you can see that these IP addresses are using the VXLAN overlay and the EVPN VXLAN control plane. Let's check out some connectivity. Now, before I go into the VM hosts, here's a quick, a short diagram that shows you the VMs. So I've got the 10.6.201.102 on vSphere host 1, and I have the 10.6.202.110. These are obviously on different subnets. So they should be using the overlay. So really what I want to achieve, and then on the other vSphere host, actually I've got the 201.101 and the 202.105. So what I'm going to do is from the 201.102, I'm going to try and reach the 201.101 on the other vSphere host. And that's using the overlay. And then from the 10.6.201.102, trying to reach the 10.6.202.105 on the other host. And I can do that with the 10.6.202.110 on the vSphere 1 host going to the other two hosts as well. Okay, let's show that. Here we are on our VMs. You can see here the 201.102 and the 202.110. So these are connected to the vSphere 1 host, and we have the 201.101 and the 202.105. So let me just, from the 201.102, let me just first try and ping the gateway. Remember that this was the active gateway IP address, 10.6.201.1. This is the active gateway address on the leaf switch. So I can ping that. And so when I go to the other VM, which is also on the 12, on VLAN 1201, I can also ping the 10.6.201.1, which is the other top of rack switch. So this proves that I can use the same IP address as default gateway for any host, for any VM that is sitting on this network. Okay, back to the 102. Let's see if I can ping across the layer 2 VNI. So I should be able to reach the 201.101. So that's between the 10K1 and 10K2. So ping 10.6.201.101. And I can reach that VM as well. So this is using the VXLAN overlay layer 2 VNI. let's check out whether I can use the layer 3 VNI. So that's basically trying to reach the 202.105 from the 201.102. Okay, ping 10.6.202.105. And this is using the layer 3 VNI. So this is using symmetric routing in the overlay. And that, and, you know, and that's also working. So this looks pretty good, pretty good. And then obviously I can do the same vice versa. So I should be able to reach the 10.6.201, say 1110, for example. Oh, and actually I cannot reach that one. So that's cool. So what's going wrong here? Ping 10.6.202.1. See if I can ping the gateway. Yes, I can do that. Oh, it's actually the 202.110, sorry. So that's the layer 2 VNI. Ping 10.6.202.1110. So that's working. I was on the wrong subnet. Okay, so ping 10.6.201.102. That's using the layer 3 VNI. So that is all working well as it should, using the EVPN VXLAN control plane and, well, obviously VXLAN tunneling in the overlay. Let's check out what we've done so far. So in video 2, we did the discovery of the switches, creating fabrics, assigning switches to the fabric, creating the layer 3 leaf spine, creating a VSX, configuring link aggregations. In video 3, we've done all the integrations with vSphere and Pensando. Video 4 is really all about preparation of the EVPN, VXLAN, and in this video, we've created this whole overlay setup with EVPNs, layer 3 VNIs. So that's kind of like concludes this video, and then in the next video, I will start to work with the Pensando Security Manager and show you some very cool stuff that we can do with the 10K switches. And that's all for now, folks. Hope you liked the video. Again, I like the thumb. Feedback, welcome, and I hope to see you soon on the next video. So thanks for watching, and bye-bye.